Now, let's now go into balancing of redox equation or writing the net ionic equation of a given redox reaction. That is a reaction that involves transfer of electrons. Now, you guys know that zinc is more reactive than copper. Yes, if you check in the activity series of metals, you will see it there. There is this table called the table of activity series of metal. Yes, if you Google it, you will see it. Okay, don't worry, later I will write it on this board. Now, if zinc is more reactive than copper, it means zinc will displace copper in any compound that copper forms. Now, let's say zinc is added to a solution of copper 2 sulfate. You know what will happen here? What will happen here is that zinc will just displace copper. It will now form ZnSO4 plus what? Cu, solid copper. So this is aqueous. This is solid. So when you put zinc in a solution, in copper 2 sulfate solution, this solution is blue in color. Remember the color of copper 2 ion. So this one is colorless. This one is brown. You know the color of copper. So now they ask you, which of these substances, which one is oxidized, which one is reduced? Now, clearly, zinc is what? Oxidized, because here it forms an ion, Zn2 plus. This one is reduced. Here, the oxidation number of copper here is 2 plus. The oxidation number of copper here is what? 0. So this one reduced from 2 plus to 0. You see? And this one increases from what? 0 to what? 2 plus. Do you see it now? So that is it. So oxidation can also mean increase in oxidation number in this sense, while reduction means decrease in what? Oxidation number. So let us continue. Now let us write the half cell equations for this. Now the half cell equations are, we have Zn gives us what? Zn2 plus what? 2 electrons. Zinc is oxidized. We have oxidation. So the other one is Cu2 plus, giving us what? Cu2 plus, giving us, that is Cu minus 2, or Cu2 plus. See, look at it here. Cu2 plus 2 electrons will give us what? Cu. We have Cu solid. We have reduction. This is oxidation half cell. This is reduction half cell. Okay. So this is it. So now, in fact, you know, if you just really want to balance this thing, in fact, you just don't write it like this. You can just write that Zn gives Zn2 plus oxidation, and Cu2 plus. Okay. That is, this side is Cu2 plus. The other side is what? Cu solid. This is reduction. Just write it. Reduction. So that's it. So you now balance the two half cells. You balance by mass, and you also balance by what? By charge. Then by mass, the mass is the same. Yeah, zinc and zinc is the same. So this one is also the same. So we balance by charge. So let us balance it. So Zn, this one will now be, to balance it, we add 2 electrons here. Zn2 plus 2 electrons. To balance this one, we now add 2 electrons. Cu2 plus 2 electrons give us what? Cu. You understand? So we just add. So this balancing is this balancing means balancing by charge. Okay, and making sure that the charge here is 0. You know, the charge here is 0. You see. So 2 plus 2 electrons is 0. That is 2 plus 2 minus 2 is 0. Okay, so this is 0 plus 2 plus 2 minus 2 is also 0. This is minus 2. Okay, this is minus 2. Just interpret it like that. So what you will do next is to do what? To write the net equation. So the net equation now becomes, you add these two equations. Once they are balanced by both mass and charge, that's when you will just write equation 1 and equation 2. So equation 1 plus equation 2, you just do it like this. Zn plus Cu2 plus 2 electrons, giving us Zn2 plus 2 electrons plus what? Cu. Now you see, 2 electron is here, 2 electron is here. See, if you are balancing this thing, make sure that the electrons in the balance reduction half cell is the same as the electrons in the balanced oxidation half cell. They must be equal. They must. So now you can clearly cancel the electron because they are both sides. So you remove it, you leave it alone, or you can, you know how we do it. So this is an equation. This is the sign of equation in chemistry. So we now do Zn, we now write the overall or net equation as Zn plus Cu2 plus, giving us Zn2 plus what? Cu. So this is the net ionic equation. This is it, aqueous. This is solid. So this is it. So this is the net ionic equation. This is how we do it. So in my next video, I will give you a more complex one to do, the one that involves polyatomic ion in my next video.